All right, in this video, we want to solve these limit questions over here, and we're going to use L'Hopital's rule for these questions. Let's take a look at the first question here. If I sub in 0 into the top, I'll get sine of 0 is 0. 7 times 0 is 0, so this full term is 0. So 0 in the top, 7 times 0 is 0, and sine of 0 is 0. So I have 0 divided by 0, which is an indeterminate case, which means I can use L'Hopital's rule, which means to derive the top and bottom separately. If I want to drive the top, I know this is a product rule right here. So I'm going to start with that. Product rule, f equals to 7x and g equals to cos 7x. F prime is just 7 and g prime is derivation of cos is negative sine 7x, but with the chain rule, to multiply by the derivation of the inside, which is 7. This is just negative 7 sine 7x. So now I'll do this whole derivation of the top over here. I'm going to write it a bit small so I can squeeze this problem in as well. Derivation of sine 7x is just 7 cos 7x, and this 7 comes from the chain rule. I just did it a bit quicker. Minus, this is my product rule over here, so f prime times g is just 7 cos 7x plus g prime times f, that's actually negative 49x sine 7x. And then I'll derive the bottom as well. So derivation of 7x is 7, and derivation of negative sine 7x is negative sine cos 7x. This can be simplified a bit. 7 cos 7x minus 7 cos 7x cancels. If I distribute the negative in with this, I'll have positive 49x sine 7x divided by 7 minus 7 cos 7x. Now if I sub in the 0 into this, if I sub in 0 into the top, the whole top will be 0. If I sub in 0 into the bottom, I'll get 7 minus 7 because cos of 0 is 1. It's also 0, so I need to derive this again. Use the product rule on the top of this one again. So f equals to 49x, g equals to sine 7x, f prime equals to 49, g prime equals to 7 cos 7x. And now I can put in my product rule over here again. So lim x approaches 0. F prime times g is just 49 times sine of 7x. Plus g prime times f. So 7 times 49 is 343 x cos 7x. And then if I derive the bottom, the derivation of 7 is 0. Derivation of this, derivation of negative cos is basically positive sine. So 7 sine 7x, and then times another 7 for my chain rule. And I can just multiply these two, simplify this a bit. So lim x approaches 0, 49. Should have probably done in the same step to save a bit of space because 3x cos 7x divided by 49 sine 7x. So now if I sub in 0, I have 0 here. This is also going to be 0. And this is again going to be 0. So again, I have 0 divided by 0. I feel like I'm doing something wrong. I can divide all of these by 49 though to just simplify it. So those will cancel and this will just become 7. So at least that makes things a bit easier. So now I have sine 7x plus 7x cos 7x divided by sine 7x. Very similar to the question. Let's try deriving it 1/3 in final time. See, I don't think L'Hopital's rule generally will go past 3 times. So this is going to be a product rule again here, but I'm going to do it in my head rather than on paper. Maybe I'll write the product rule on the side over here. So f equals 7x, g equals cos 7x, f prime. I really hope this works. G prime is -7 sine 7x. So let's do this derivation hopefully one last time. So sine 7x is 7 cos 7x plus, this is a product rule here. So f prime times g, 7 cos 7x. And then plus g prime times that, -7 times 7x is -49 x sine 7x. And then if I derive the denominator, sine 7x, derivation of sine 7x is just 7 cos 7x. Okay, let's sub in 0 into this one, and hopefully we'll not get 0 over 0 again. You can always distribute this into the bracket and combine like terms as well, but I'm not going to really bother with that. Let me just sub in the 0. So this is going to become 7 plus 7, and then this is going to be 0. This is going to be 7. So we do get a good number. So that, thank God, the problem is going to be done over here. So I'm going to sub in my 0 into this. Cos of 0 is just 1. 1 times 7 is 7. Same thing, this is just 7. This will all be 0 because x is 0, which means the whole thing will multiply as 0. Bottom is just 7. Final answer is just 7 plus 7 over 7, which is 14 divided by 7, which means that the limit approaches 2. We finally reached our solution. Just took 2 times of L'Hopital's rule with the product rule over here. Okay, let's go to the second question here. I'm going to squeeze it in this tiny little space. Hopefully that's going to be enough. So if I take a look at this question, if I sub in 0, the plus just means we have a domain of x is greater than 0 because you can't ln 0, you can't ln a negative number. If I sub in 0 into this, I'll have square root of 0, which is 0. Then if I sub in 0, I can't really sub in 0 over here, but remember for a long graph, as we approach 0, the long graph is approaching -infinity. So technically this calculation is 0 times -infinity, which again is one of the indeterminate cases of L'Hopital's rule. So we got to do L'Hopital's rule over here again, but how do we do L'Hopital's rule? We don't have anything dividing. So what I'd like to do over here, let's change this to an exponent first. I'll leave this the exact same, and then I'll move this to the denominator. And I will change this to ln of 7x divided by x to the negative half. So now I have a numerator, I have a denominator. I can derive this using L'Hopital's rule. Let's derive the top first. Derivation of ln 7x is 1 over 7x times the derivation of the inside, which is 7. So 1 over 7x times 7. And the derivation of the denominator is just -half x to the -3 over 2. Now all we have to do is simplify this double fraction basically. So 7 and 7 cancel. And then we just have 1 divided by this whole thing over here. So that can be simplified. Basically, this 2 can be moved all the way to the top. The whole thing is a negative over here. So I'm going to combine the two constants first. Just turning it into a -2. Then this x and this x can cancel because this is the denominator of the numerator and this is the numerator of the denominator. Basically, these two terms are multiplying. If I multiply these, I'm adding the exponents. So 1 plus -3 over 2 is just x to the power of -1 over 2. This can be simplified a bit further, I can make my exponent positive and move this term to the top. Just negative 2x to the positive 1 over 2. And then if I sub in 0 into this, just negative 2 times 0 to the 1 over 2. 0 to the 1 over 2 is just the square root of 0, which is 0. So that's negative 2 times 0, which means that my limit is approaching 0 as x approaches 0 from the positive side. That was a bit of an easier one. Let's go to the third question over here. I have x to the power of x in this question. Whenever you have x to the power of x, you have to do your steps of using a ln, but we don't have two sides in the equation here. We actually have to create two sides when you have x to the power of x. Once you create two sides, you want to ln both sides so you can bring down your exponent. And then I'm just going to bring down my exponent. You can either bring down just the sine x, or you can bring down the entire 4 sine x. It doesn't matter. Both of them will give you the exact same solution. I'm going to just bring down the entire 4 sine x. Oops, ln y. 4 sine x ln x. So, and again, I forgot to mention, if I subbed in 0 into the original question, I would have 0 to the power of 0, which is again an indeterminate case, so we'd have to do L'Hopital's rule. Same thing over here. If I sub in 0 into this, I can't really ln 0 over here. I also have a ln on the other side, so I can't really sub in. I can sub it in, but can't really sub in 0 into this ln over here. I mean, technically, you could pretend like it's 0 plus, which would mean this would be negative infinity. So you just have 0 times negative infinity, which is still indeterminate. So we have to do L'Hopital's rule over here. How do I do L'Hopital's rule if I don't have a denominator? Well, I want to create a denominator. And when you have a trig case, you can always use your reciprocal trig functions. You know, sine x, the reciprocal of sine x is cosec x. Means I can turn this into 4 ln x divided by cosec x. Now I can do L'Hopital's rule for this question. So I don't know why I keep writing the i's there. Keep mixing it up with the limbs, I guess, and the lns. Derivation of 4 ln x is just 4 divided by x. Derivation of cosec x is negative cosec x cot x. Now all I have to do is simplify this. So I'm going to combine my two denominators in this question. Then I'm going to turn the two reciprocals into the originals. That's 4 cosec's reciprocal is sine x, cot's reciprocal is tan x, and then divide by negative x. So now let me sub in 0 into this. Let's see what happens. If I sub in 0 into this, sine of 0 is 0. So the whole top will be 0. Bottom is also 0, which means that I have 0 over 0, which is indeterminate. So I have to use L'Hopital's rule again. For simplicity purposes, I'm just going to move this negative to the top, keep it with my constant. Makes things a bit easier as well in this question. If I'm deriving the top, I have to do product rule again. So f equals to negative 4 sine x, g equals to tan x, f prime equals negative 4 cos x, g prime equals sec square x. Let's put in my product rule all in this question. On y equals to lim x approaches 0 from the positive side. F prime times g is -4 cos x tan x. G prime times f is -4 sine x sec square x. And then this is all divided by the derivation of the bottom of x is just 1. Let me sub in 0 into this now. Cos of 0 is 1, tan of 0 is 0, so this whole term over here is 0. Sine of 0 is 0, sec square of 0 is 1, so this whole thing is 0. I just have ln y equals to 0 divided by 1, which means ln of y equals to 0. If I move the y to the other side, the ln to the other side, it becomes e to the power of 0, and e to the power of 0 is simply 1. So my final answer for this question is the limit approaches 1 as x approaches 0 from the positive side. And let's go to this last and final question here of this video, which again, I have x to the power of x. Means I'm doing the same thing here. I'm going to make it an equation, and I'm going to ln both sides. I'll do both of those things in one step to save a bit of space in this question. Bring the exponent down as well, which you technically could have done in the same step. By the way, if I sub an infinity into this question, I'll have infinity to the power of 1 over infinity, which is infinity to the power of 0, which is another of the L'Hopital's rule indeterminate cases. Continuing here, I'm going to bring my exponent down. Then I can just simplify this and rewrite it. If I sub an infinity here, there's no point because I'll still have infinity divided by infinity, which is the L'Hopital's case again. So you have to do L'Hopital's rule once in both these cases, or at least once. So let me start by deriving top. If I derive the top, I will have derivation of this is 1 over 1 plus x squared times 2x. Derivation of the denominator is just 1, so I technically don't need that anymore because anything divided by 1 is just the same thing. So I'll just rewrite this as lim x approaches infinity 2x over 1 plus x squared. Sub an infinity into this again, I'll get infinity divided by infinity again, which is L'Hopital's rule again. So I'm going to derive this one more time. If I derive the top, the derivation of 2x is just 2. Derive the bottom, the derivation is just 2x. 2 and 2 cancel. So this is just ln y equals lim x approaches infinity 1 over x. And sub an infinity into this now, so ln y is just 1 over infinity. 1 over infinity is just 0. That's not indeterminate, so ln y equals to 0. Move the ln to the other side, so y equals to e to the power of 0. E to the power of 0 is just 1, so the limit again just approaches 1 as x approaches infinity in this question. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.